Hello everyone, welcome back to our channel. So in today's video, we are going to solve a Armstrong number. So before starting the topic, let me ask you one question. So in many placement interviews, especially in service-based companies like TCS, Infosys, Wipro or Accenture, they ask how to write. They ask write a program to check whether a number is an Armstrong number or not. And if you don't know the logic clearly, you may struggle. So today I will make this concept very simple and clear. So let's see what exactly is Armstrong number. So an Armstrong number is a number that is equal to the sum of its own digit, each raised to the power of the number of digits. So it is also called as narcissistic number or else a pluperfect digital invariant. So just PDI. So our important ideas power depends on the number of its digit. For example, so here is some basic definition I have given. So if a number has a n digit, then our formula will be like a digit into n, or just a digit power n plus a digit to power n and up to rn. And if that is equal to our original number, then that is a true. Then that is our Armstrong number. So this formula is simple, but this is very important for to find a Armstrong number. So let's see an example. So here we have taken 153. Okay. So now 153 we have three digits. So we are going to power by 3. Each and every digit we are going to power by 3. So for example, here we have a 1. So 1 power 3 which is 1 and 5 power 3 which is 125. And 3 power 3 we'll get a 27. So if we add this, we get a 153. So our digit value and a power added value, which is our sum of n power digit. Digit. So our sum of digit power n is equal to our original number. Then that is called as an Armstrong number. Otherwise, it is not an Armstrong number. So for more example, I have already tell about the 153. So let's take for 370. So for 370 also we have a 3 digit, right? So if we take a 3 cube, we get a 27, right? So and 7 cube, we get a 49. So 0 cube, we get a 0. So if we add this, what will get? So let's take another one example also. So I have already told about the 153. So let's take a 370. So if I cube by its digit, a total digit, and if I do a sum operation, I'll get a 370. So for example, 3 cube plus 7 cube plus 0 cube, I'll get a 370. So this also satisfies its condition. So that is what the Armstrong number. So instead of 3 digits, so here we have taken 1634. So here we have a 4 digit. So that we raise each digit to the power of 4. So for example, 1 power 4, 6 power 4, 3 power 4 and 4 power 4. And if we add this and we get a 1634. So if our sum of digit value and which is sum of digit power n is equal to our original value, then that is also known as a Armstrong number. So I think you will get it. So if you understand this clearly, subscribe to our channel and hit the bell icon for more placement and programming videos. So let's continue. So here we have an algorithm. So let's see the algorithm. So at first take a input and we have to count the number of digits. So and then only we can rise to the power, right? So and we have to extract each digit and raise the digit to the power of its total digit and add the values and compare with the original value on the sum value. So if it is equal, we just print it is a Armstrong number. Otherwise, it is not an Armstrong number. So here is our pseudocode. So at first, we have to get the input from the user, and we are storing our original value in another one value. storing our original value in the other variable, and we are initializing sum equal to 0. At first, we have to count our digit, right? So for that, I'm just giving a variable digit equal to 0. And after that, I'm just setting in a temporary variable, I'm just storing my number. In a while condition, I'm checking my temporary variable less than 0. So after that, I'm just splitting my last digit. I'm just removing my last digit and adding a digit. I'm just counting my digit. Okay. So from this, I'll get my count of the digit. And in a step 2, I'm going to calculate the sum of the digits into digits, which means digits into n, digits power n. So here I'm setting another one temporary variable. In that I'm storing my original number. So as like in a while loop, I'm giving a condition temporary greater than 0. And in a digit loop, I'm just taking a digit as my variable, and I'm just extracting my last digit, and I'm sum with the cube value. I'm just summing. I'll just do a addition. Here I'll do a addition and a sum of digit. And digit power. Here I'll do a sum plus digit power digit. So if I have a 1, if I have a 143, I have to count 3 into 3, right? So 3 into 3 and my sum value. At first my sum value will be 0, and I'll do a 3 into 3 plus sum. And if my value is 5, and I have to do 5 into 3, which is 5 power 3 plus my previous value, which is 3 power 3. So I have to do a sum of digits power digits. So after that, I'm just removing my last digit, and from this I'll just get a sum of digits power digits. And in a third step, I'll just compare my sum value and my original value. So if it is equal, I'll just print Armstrong number. If it's not, I'll just print it is not a Armstrong number. And we'll end the program. So I have said, right, for a program, if I give an input as a 153, I'll get as a Armstrong number. And if it is a 123, it's not a Armstrong number. So let's do a program so that we can easily understand. So I have given an Armstrong number. So class is created. Inside the class, we have to use our main class. So in our main class, our scanner class to get the input from the user. So scanner new scanner inside system.h. So now we have to get an input from the user. So for that, int n equal to se.nextInt. So in our step 1, so let's first store in another variable. So for that, I'm just giving so let's give a temp variable, okay? So in a temp variable, let's just store our n value. So after that, what is our first step? Our first step is to count the how many digit is present in a number. So for that, I'm just giving a digit. So digit equal to 0. So after that, I have to find. In our step 2, we have to do a sum calculation, right? So for that, I'm using a sum. So sum equal to 0. So in a third step, we have to do a comparison. So for that, I'm just taking my temporary variable. In a temporary variable, I'm just storing my n value. Okay. So let's do our step 1. So in our step 1, we have to count the digit, right? So for that, let's get a while loop. In a while loop, let's give a n less than 0. So we'll get a digit, right? So to get a digit, we have to extract our last digit or remove our last digit, and we can count that. So for that, I'm just giving so let's give a n division equal to 10. So here the last digit will be removed, and we just do a digit increment so that we can know how much digit is present in a number, right? So let's just give a printing statement here. So to know how much digit present here. So in SOPLN, I'm just giving my digit count. So inside, I'm just giving some content as a digit count. So after that, in step 2, we have to do the sum of digit power or individual digit, right? So for that, let's take so in our temp variable, let's store our original value. So n. So the in our temporary variable we have store our n value, right? So let's use that temporary variable. So in our while loop, I'm just passing my temp. If it is greater than 0, the loop will run. Otherwise, it will terminate. So inside the condition, at first, I'm just going to extract my last digit. So for that, I'm using rem as my variable, which is my reminder. So in that, I'm just extracting my last digit, right? So for that, I'm using a model operator. And after that, mm, let's do a calculation. So sum plus equal. So which means sum equal to sum plus. So we will add here and we have to do a power, right? So which is our digit power, our reminder, which is our reminder power digit. So if my digit is 3, I have to do a reminder power 3, right? So like this we have to do. So for that in Java, we have a function, our power function. So for that, our map dot power. So at first, I have to pass my base value. So my base value is reminder. And for the power function, my value is digit, right? So I'm passing my digit value. So let's remove our last digit. So for that, let's take our temp division equal to 10. So here we will just remove our last digit. So we have do a sum operation here and our third step, which is comparison. So as for the comparison, we have to check a value. So if my sum is equal to my original value. So which I have temporary variable, right? So in a temporary variable, I have stored my original value. So if it is equal, I have to print that it is an Armstrong. Okay. So if it is not, I have to print it is not an Armstrong. So let's run this. We have got a error. Possible lossy conversion from double to int. Okay, fine. So here we have declare sum equal to sum plus math dot power of rem and digit. So here let's do a type conversion here from int. Okay. So let's run this again. So see here, we don't have any error in this. So let's run. So let's give 153. So we have to check 150 is a Armstrong number or not. So see here. So here we have a 3 digit and it is a Armstrong number. So let's run this again. So let's give a 143. So here also we have a 3 digit and it is not the Armstrong number. So here is our time complexity. So time complexity is always depends on the number of digits. So if digit counting is big of n, a loop will execute up to big of n times. So overall complexity is big of n. So if checking ranges, it becomes so for range checking, it become a big of n square. So you all have it up. So what is the purpose? I have to learn an Armstrong number. So where it is used, right? So it is used to mathematical curiosity and number theory studies, and it improves the programming logic building also, and understanding the loops and mathematical operations also. So this question mainly tests your logic clarity. So common mistakes students will make is what using fixed number 3 for all numbers. So and forgetting to count the digits, or else modifying a original number without storing it. So not using our temporary variable, and avoid these mistakes in interviews. And in interviews, they may ask like check Armstrong number and print the Armstrong number in a range and count Armstrong number in a range. Sometimes they combine with loops or functions. So practice properly. So Armstrong number depends on the number of digits and sum of digits power n must equal to the original number. So it improves the logical thinking and very important for placements also. So always understand the logic first, not just code. And practice writing programs without copying and revise basic concepts like loops, operations, and math functions. So in interviews, explain logic clearly before coding and always dry run your code with example like 153 and confidence and clarity as a selection. Okay. So thank you for everyone. If you have any questions, I'm happy to answer. Have a nice day. So I'll see you in the next code. Happy coding.